You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech Podcast. I have Leslie Oliver Karpas, co-founder of Lexset, Lexset. The website is lexset.ai. So, Leslie, thanks for coming. How are you doing today?
Doing fantastic. Thank you so much for having me on the podcast today.
Oh, yeah, no problem. So tell me about Lexset. What does that mean? Is it an abbreviation of something? And what's the premise of the company?
Lexset is a AI for interior design. And the idea is lex, which is the Latin word for rule, and set, so thinking about set theory, that interior design can be boiled down to thinking about what groups of objects go well together. And so Lexset's goal is to help make that process easier, creating the right set or the right group for any given space.
Do you have an eye for interior design yourself?
I do. I started my career as an architect a long time ago. And that exposed me to a lot of 3D technology, like 3D modeling and 3D scanning and 3D printing. And, my last startup was in the 3D printing space, but I still have that, design bug sort of deep inside of me. And when I had the opportunity to start this one, the idea of being able to combine some of the different areas of experience I'd picked up along the way, to apply that to my original mission of, helping people make their lives more beautiful was something that was really compelling for me.
It's interesting. This is, I don't know if these have a name, but this is like part of a set of problems I've been thinking about recently. Like, for instance, I'm not good at interior design. I can walk into a place and say, wow, it looks really good in here and it has a certain feel, but I couldn't tell you how to do that. And same thing with, what makes someone beautiful or not. It seems to be common around the world that people think, oh, these features, make someone beautiful, but you may not know that like right off the bat. So I guess these heuristics, you have that ability to know what looks good, and then now it's your job to take an AI and incorporate all that stuff into it. So how do you do that?
So that's definitely like one of the theses, I guess, that Francis and I started this company around, is that he and I were both originally trained as architects before we, became technologists. And, in architecture school, you get taught a lot of rules that make design good design, rules about circulation, about material, about color palette, that there are a lot of things that, good designers employ that aren't magic. It's not subjective. It's actually quite objective based on the needs and the functionality of a given space. And, being consistent with the types of choices you're making about that space, whether it's sticking to a certain set of materials or a certain set of colors, that, if you execute with integrity throughout a design, the end result will inherently be sort of good and appealing. And, a lot of people out there don't have the design eye that he and I have. And so what we wanted to do was package that up for everybody in a way that was accessible for non-designers to be able to say, I want this to be a good design, please help me. And so we're trying to automate as much of that process as possible, starting with, the vision component of it, that, inherent to any design problem, you need to understand the ingredients that are going into it. And so Lexset's, first mission is to create a really good machine vision AI that can identify furniture objects in a scene, in a photo, in a space, and, apply attributes to all of those objects. That's a modernist table, that's an industrial chair, that's wood, that's fabric, that's stone. And based on being able to see the properties of different objects in space, that will allow us to teach the AI what good design is by exposing it to lots of good design. So, I mean, between Architectural Digest and Dwell and Surface and a few dozen other really great design magazines out there, there are lots of good examples of design that exist. And a lot of those examples, especially in design journalism, are coupled with natural language descriptions of those designs. And so we're trying to create an engine, as it were, that eventually will be capable of ingesting a lot of that pantheon of good design that's out there to teach our AI what good design is. But step one, which is the near term, is just focusing on that vision component. A lot of what I'm talking about is, a few years down the road, once we have the vision component dialed in.
So, I mean, what's the end goal for this? Eliminate the need for architects, or what will the AI be able to do that people won't be able to do, or will it democratize access to good design? I mean, what's the goal?
So I would say that democratizing access to good design is absolutely core to our mission of helping people make their world more beautiful. I don't think we could ever replace the human and the design process, but the goal here is to help them go a lot faster. A lot of the design process involves many tasks that are extremely tedious. Hunting through catalogs, hunting for product, trying to find that right thing to complete a look of a design that someone's trying to create. And we're creating a toolkit that will help a human designer do their job a lot more quickly and with a lot less pain.
And I guess people that aren't designers, it'll help them create nice designs, right?
Oh, yeah. And that goes without saying. I mean, there are millions and millions of people out there who would like to have better design in their environments, but they can't afford an interior designer. And for all of those people, Lexset will be, a go-to to help people make better decisions about the space around them.
So what have you seen as the power of good design? What can it do, and how does it affect people?
So I think that there have been a number of studies that show that good design can really enhance productivity because it enhances overall state of well-being in the sense that we're in an organized environment that has, an overall sense of integrity to it. Beyond that, it's also about making space more functional, whether that's appropriate places to sit, appropriate places to work, spaces that can be intuitive so that people know how to navigate them. They know where the exits are. They know where the storage is. They know where private space is. They know where public space is. The good design kind of tells you how to take advantage of the space around the individual. And, that's something that, we'd like to highlight. But, one of the things that I guess we're really focused on in the near term is simply helping people associate products together that, like this couch goes with that table that will go well with that chair, such that, the design language of a space is consistent and has a lot of integrity to it. What makes bad design is random choices or things that are incongruous being in the same space. And so we're trying to eliminate or, massage away some of that incongruousness that infects spaces and turns, a good space into a bad space.
Okay. So I guess you have a bunch of work to do. How do you collect images of good design and, versus bad design? Like, how do you build your data set?
So that's the best question you could possibly ask us. So one of the things that we've done at Lexset is we've created a synthetic data generation engine. When you're building an AI, it's really important to have great training data. And that means lots and lots of photographs and images that have good metadata, good tags, good natural language descriptions about what each one of those images are. And the difficulty, particularly when it comes to furniture and interior space, is that a lot of that data doesn't exist. So we had to create an engine to create it. And what happened is we got a very large furniture brand that I'm under NDA, not to say which, but they have an extremely large CAD library of furniture, of 3D models of furniture. And we got them to give us a royalty-free license to that database of about 80,000 objects. And what we did is we took those objects and pumped them through our engine that renders each object a few thousand times from different camera angles and different lighting conditions and different material states, so that we're really, really good at recognizing that object in a photo or in real world space. And so using this engine, we've created about 500 million images or so to be the training data of our neural network.
So have you run the network? Like, at what stage are you at with things?
So the network exists. About those 500 million images or so currently power, I think, 12,000 classifiers that describe the objects in any given image. And so that's being able to look at a photo and say, that's a couch, that's a table, that's a chair, but that couch is modernist, it's gray, it's fabric, that table is postmodern, it's white, it's wood. Being able to get to, a deeper level of description of each object so that we can look at the correlation of those descriptions to one another and then make predictions about what will go well in that scene.
Okay. So what's an example? Do you have I don't know, let's take like a living room or a commercial space, a lobby or something, can you give me an example of, I know it's hard not to do it visually, but what can you tell me that would, give people an idea?
So one of the use cases that I'd say is, in the immediate near term for us is creating a plugin for any furniture company's website where, let's say you've got a photo you like on Instagram and you want to make that look of that photo in your own living room. And maybe you have a table that looks like the table that's in the photo, but you don't have any of the other stuff in the photo. So you need to go and find that couch and that lamp and those other objects. So using this plugin we've developed, if a furniture company has it, you'll be able to upload that photo to their website, and that photo will then reveal all of the products that company sells that's like the objects in that scene. So now all of a sudden you can buy those objects that are in the photo you like, and hopefully at a far more affordable price point than the objects that were in the photo itself.
Oh, okay, I gotcha. Huh.
And so
it may not just be price. It may be just, hey, I love how that bedroom looks, and I love the lamps and the furniture and stuff. How can I get stuff that looks similar so I can create the effect for myself? And maybe if it was sophisticated enough, I could be offered choices, like this lamp that looks like a leopard or something. There's two choices. There's like a high-end version and a low-end version, and here's how they look, and they're similar and all that, and that kind of thing.
Yeah, I mean that's exactly right. And so the idea of using visual search for furniture is a relatively new concept. About 3% of furniture companies right now have a visual search tool, and those 3% are the three biggest, or the few biggest players in the industry. So House has a good visual search tool, Wayfair has a good visual search tool, and Overstock has a good visual search tool. But after those three major players, that's it. And so what we're doing is we're building a tool that all of the mid-tier and smaller companies in the space can employ so that they can have that feature too.
Okay. So where are you at with the project? Like how far along, and what's literally, what stage is it at right now?
So we are currently in some closed pilots with a couple of major players in the space, one very large contract furniture company, an interior design company, and then a smaller furniture player right now. And they're really happy with the tools that we've made for them. And I expect you'll see them launch in the next quarter or two. But I'm under NDA not to say who those players are today. But so we're working away on those pilots. And then we also have a couple of related to furniture but non-furniture use cases that we're working on. So there's a robotics company that does home robotics that we're currently doing a pilot for to help their robots understand what a couch is and what a table is. So you'll be able to say, hey, robot vacuum, please clean in front of the couch, and it will actually know what a couch is. And so, so this is going to be used
not just for design, but it's going to be like a resource, a visual data set that can be used for all kinds of AI applications.
Right. So what we've built is an AI that can take 3D models of objects and then create a good visual recognition system from those models. So that's pretty much good at anything that has a 3D representation of it, which is to say everything except for apparel. That's the one place where we're really weak, is we're not good at fashion, because clothing is a flexible soft body. And so there are no good 3D models that represent clothing, so we can't run it through our synthetic data engine. But for anything that's a solid body object, from a car to a piece of furniture to an industrial part, our system is very good at recognizing that in real world applications.
Okay, interesting. Does this work for facial recognition? I mean, you said it's weak on clothing apparel, which I understand, has its own unique challenges. Like, what kinds of things is it strong in? What's it weak in? Would this apply to facial recognition? Like, what are all the different possible uses of it?
So in theory, it could be used for facial recognition, but that's really not where we're pointed with it, just because there's so many other companies that are doing that and focused on the nuances of that particular problem. We're really focused on interior design and furniture because when it comes to the future of AI and what all these different AI startups like ourselves are currently working on, it's getting to deeper levels of sophistication with how you describe things. And what I mean by that is, like, let's say you look at the world of like chatbot companies. You've got all these companies right now that are developing what are called Alexa skills, which are very specific areas of conversation that they happen to be good at, whether that's taking a restaurant delivery order or being a technical support chatbot. There are these areas of specificity that those AI companies in the chat space are dialing in. On the visual side, this is true as well. There are a whole bunch of AIs out there that are good at fashion, where we're not good at them, or not good at it. What we're focused on is the language of space and furniture. You know, something being modernist versus postmodern versus industrial. That requires a lot more nuance and understanding. And so that's sort of a niche that we see is available to carve out. And so we're focused on that as a niche. It's not just about what we're good at recognizing, it's about how the semantics of the language get dialed in for a very particular use case, if that makes sense.
All right, I got you. So again, what are some of the unique challenges with different kinds of objects? You know, what's the world of machine vision look like? How is it divided?
So first you've got, what are the typical camera angles that something will be viewed from? So we want to focus on the camera angles that are typical to a given use case. So when we ended up working with a company that's doing the robotic vacuum cleaner stuff, we had to re-render the entire training set from 1 inch off the ground because there was no training data taken from, no photographs that are taken from the top of your shoe. So we had to take all the furniture in our data set and re-render it from the perspective of that particular robot, and create a whole new set of data that was from that camera angle. And so getting into, the types of camera angle that is typical to a use case, that's one nuance. Another nuance is, what's called the blind man and the elephant problem. So like if you look at a couch straight on, it looks like a couch. But if you look at a couch from the side, it can kind of look like a chair. And so we have to then do a whole lot of like inferencing about what are the subtle differences between how a couch looks in profile versus how a chair looks in profile. And so you get into, like the back of a chair might end up looking like a rug because it's a square, colorful object. And so getting into those like little differences of, how something looks from a given perspective, and being able to make the data set rich enough that it can kind of understand that it's only got a partial camera angle or an occluded object that's going to sort of pollute its ability to get the object right on first glance.
Okay, interesting. Yeah, it's amazing how the human brain can figure that stuff out, and it's so difficult for machines to. I guess the lighting would also change things, the distance, the angle.
That's all absolutely correct. One of the things that I guess we've decided to focus on a lot is lighting. So when we render an object, we have a few thousand separate instances of our rendering engine that renders that object in every possible lighting condition that we think it's likely to be seen in, so that we have, a lot of bad lighting of objects. And when it comes to the photographs that are typical, especially in the furniture space, they're all studio shots. So every photo has perfect lighting, but the real world never has perfect lighting. So that's why it's important for us to simulate bad lighting conditions.
Well, all right. So what kind of improvements are happening that will assist, machine vision? Better cameras, higher megapixel, more views of an object. I mean, what kinds of things can make a really robust library that's super useful?
So Apple and Google have done a lot on this front with ARKit and ARCore, their augmented reality frameworks, that have done a lot to provide some great data sets around point clouds of objects in space. And The next generation of smartphones that are going to start rolling out later this year and next year are all going to have built-in 3D cameras on the back of them. So 3D scanners are about to be ubiquitous. And the addition of that point cloud data coming in from photographs and 3D scans of real world objects is going to dramatically increase the supply of rich data to train vision systems on.
Okay. I mean, are there any specifics in there that that we haven't covered that you think, again, are there any advancements or developments that you think are going to be a big boon to anything in regards to machine vision?
I do. So because of that increase in the number of 3D point clouds of real world situations, what that is going to do is it's going to create enough data that we'll be able to inference what a three-dimensional object is from a two-dimensional scene. So we'll be able to create a 3D map from a single image with the kind of data that's going to start to become available based on all of the 3D scanning that we expect to see once, every iPhone and every Android phone has a 3D scanner on the back of it. And so that'll be a big sea change, being able to do 3D from 2D. And, that's what we see coming in the next couple of years.
Interesting. Yeah. So in the future, you'll be able to, they're starting to do that already on cell phone cameras a little bit. You can have take an image and it renders what it thinks it looks like in 3D in like a real limited way. Maybe it has like 3 frames that cycle back and forth, so it looks like something's moving. But I guess in the future, you'll be able to take a 2D image and figure out the distances and everything and the morphology of all the shapes and recreate a 3D scene.
Yeah, and one of the reasons why that's very exciting for Lexset is that will give us the ability to recreate a layout of furniture in a room from a photograph of the room. And once we can do that, we'll be able to get to predicting what objects should go into a space, because we'll be able to take all of that design journalism I was talking about earlier and turn those into 3-dimensional layouts of all of those scenes and use that to create predictive analytics for what should go in any given space and where.
Yeah, like if someone wants to put in, a table into their living room, you could have 3D pictures of the table or know the dimensions of it and literally accurately place it into the scene, and you would see where it is and how it looks.
Exactly. And so being able to factor scale of a given scene into the search for the furniture for that scene will be a big difference maker in helping people choose the right objects for a space once scale is a factor, which it isn't today.
What about beyond design? I'm imagining looking at like old photographs and what would we find out if we could, re-render them in 3D and see things happening? I just wonder, it's like kind of accident reconstruction in a way, or scene reconstruction. I wonder what things we would see that we didn't see beforehand,
I'm sure there are a whole slew of industrial use cases around that. Looking at the way that machines function, the way that parts work together, I think that there's a lot of photos and videos of all kinds of stuff that suddenly we'll be able to reproduce in 3D and create simulations of. And that should just, increase the amount of simulation data out there. That hasn't really been where my head's been at. So I wish I could brainstorm more on what some of that looked like. But, at a high level, I think that there's a there, so to speak.
Well, I imagine too, like taking tours of homes, for the real estate industry, or or for industrial design or regular design. If you're able to not only place objects in a room, but walk the room or rotate it and literally experience the room in 3D as if you were there, that would give people a much better feel.
So the real estate industry has been hip to this for at least the last few years. There, between 3D cameras and simple 3D scanning from companies like Matterport and Occipital, there have been a lot of interesting, advancements and like virtual room tours of space. One of the things that Lexset's really interested in is being able to look at all the furniture that's in someone's home and then help them visualize what that furniture might look like in a home that they're thinking about moving into. So being able to instantly virtually experience, what does this new home look like with my stuff?
Yeah, I know it's probably not a big deal, but you could even image all the stuff. Let's say you're going to hire a moving company. You can image all the stuff, and the moving company will be like, all right, you got, 3,000 pounds of crap, and yeah, it'll fit in our trailer, and this is how much to move you. I guess it could have a lot of incidental uses that are unusual.
Well, so going back to that moving application, that's something that we're thinking about quite a bit. Can we help the moving company, A, pack the truck most efficiently as possible, and then B, take all the stuff that they packed and put it into the right places in the new home when they get there. So coordinating the entire move from packing the truck to unpacking the truck, so that all happens really efficiently, and that the homeowner doesn't have like a whole bunch of like coordination that he has to do of the movers when they get to the new place. The movers can just pull out their phone and be like, okay, this couch goes there, that table goes over here. And, really streamlining that process.
That's really cool. I once saw something about, when Obama was president, like they have some kick-ass movers. Their movers got all their stuff, cataloged it all, went to the White House, had a place for everything. They packed them up, they moved the stuff, then they unpacked everything and put it in the place. So they literally walked in and had nothing to do. Everything was in its place and done. So with your abilities, you'll be able to, give people, mostly that experience, which is super cool.
Yeah, that's one of the things that we're really amped of giving to the world is just, like making the whole process of moving a lot less painful.
That's really cool. Well, I'm excited now. So very good. So what's the best way for folks to find out more and experience what you're working on? How do they get in contact?
So info@lexset.ai is a great email address to direct inquiries to. The website, www.lexset.ai, has a lot of information there for anybody who's curious. Right now, we are focused on being a B2B company. So we're trying to sell our tools to all of the furniture companies that are out there. So hopefully every furniture company real soon will be using Lexset Visual Search to power their search engines to help with discovery and conversion for their shoppers. One of the things that Lexset can do is we can take existing marketing collateral, so like the beautiful gallery photos that most of these furniture companies have, and make them directly shoppable instantly. So instead of having to have a web developer manually put little clickable buttons on those photos, we can do that instantly so that each photo on the website, you can just click the furniture and buy it if you like it.
Leslie, thanks for coming on the podcast, and I appreciate all the insight, and it's going to be really cool to see what you guys do with everything.
Hey, I really appreciate it. Thank you so much for having me on today.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.